In this video, I'm going to be solving some past paper questions of O-level art math vectors, and I've taken out a couple of questions where we'll be dealing with addition of vectors, subtraction of vectors, position vectors, or collinear vectors and stuff where you have to find lambda, alpha, not alpha, sorry, lambda, mu, and basically constants, and we will find out as we go along. But yeah, I will not be covering constant velocity problems in this video. I'll do that in the later video, because for that it's best that I first give you guys some detailed notes and then do that. But in this particular video, I will just be dealing with questions that have like the concepts that I just mentioned earlier. Anyway, so let's get straight to it. So in part A, in fact, let's read the question. This question, I should mention, is from October November 2020, paper 1, variant 3. So in part A, it says find OX in terms of A and let's read the question. It says the diagram shows the triangle OAC. So keep looking at the figure also. The point B is the midpoint of OC. Alright. The point Y lies on AC such that AY intersects at B at the point X, where AX and XB are in the ratio 3:1. It is given that OA is equals to A and OB is equals to B. Find OX in terms of A and B, giving your answer in its simplest form. Okay, now I'm going to read the question again, and this time I am going to pick the important information and apply it to the diagram that we have here. So the first thing it says, other than the fact that it's a triangle, it says that B is the midpoint of OC. So that instantly tells me that BC vector will also be equal to B. And then it says the point Y lies on AC. So I'm looking at Y such that OY intersects AB at the point X, where AX and XB are on the ratio 3:1. So that basically means AX is 3 parts and XB is 1 part. So altogether, AB has been broken down into 4 parts. AX takes 3 of those, XB takes the remaining 1 part. Okay. Then it says find OX in terms of A and B, giving an answer in its simplest form. If you look at the marks, it's a 3-mark question. So that means this will require some decent amount of working. Anyway, so I need to get my hands on OX. Now let's see what I have to do in order to get my hands on OX. In order to find OX, I can go from O to A and then from A to X, and that will take me from O to X. Okay, now I may have one of the two vectors and not the other. So OA is given as A. Now I don't have AX, but I have all the ingredients in order to work out what AX is equal to. Now if you come back, AX is part of AB, okay? And if I want to work out it's how many or what fraction of AB is it equal to, so we just saw that AB has been broken down into 4 parts and AX takes 3 of those. So that means as far as AX is concerned, so I'll write it over here, that AX is basically equal to 3/4 of AB. So that means I can figure out what AX is equals to first if I can figure out what AB is equals to. So can I figure out what AB is equals to? Absolutely yes. All I got to do is I got to go from A to O and then from O to B. So that means that AX here can be worked out by simply taking 3/4 of, now since I'm going from A to O, that's going to be minus A, and then I'm going from O to B, so that's going to be plus B. So this is what AX is equals to, so I'm just going to replace it over here. So plus 3/4 of minus A plus B. Remember, the question wants us to give our answer in its simplest form, so we got to do that. So A minus 3/4 of A plus 3/4 of B. Now let's see what is this equal to. Let's do 1 minus 3 divided by 4. That's 1/4 of A. So 1/4 of A plus 3/4 of B. If you want, you can take 1/4 common and write this as A plus 3B, but that's entirely up to you. Okay, then it says find AC in terms of A and B. So this is a 1-mark question. That means hopefully this will not take us very long. And yep, that's true. In order to get from A to C, I can go from A to O and then from O to C. So I'm going to do just that. A to O, you can see, is negative A because we're going in the opposite direction. And O to C is going to be B and B, which is basically 2B. So AC, as we just saw, is equals to AO plus OB. So we're looking at minus A plus 2B. And there you go. We immediately have what AC is equals to. Okay, now these are the parts that I really want to cover. And up until now, you must have noticed that these concepts are more or less the same as the ones that we were doing in math. This is where things get slightly more complicated. And honestly speaking, if you have the basic understanding of vectors, if you've understood that, then this will not be a problem. And if you do want to revise the basic understanding of vectors, I can suggest you watch the math video on vectors. That will definitely help. And then you can come back and do this. Okay, so it says given that OY is equals to h times of ox, and we have to find ay in terms of b, a, b, and h. Okay, so I think it's best if we take a screenshot of this and bring it down. Okay, so remember we worked out bc to be equal to b, and here the question says that oy is equals to h times of ox. So, and we have to find ay. Okay, so that means I gotta use, if I want to find it in terms of h, I gotta use oy somewhere, because that's what will give it to me in terms of h, since oy is equals to h times of ox. Okay, so if I want ay, and I have to use, like I said, I have to use oy, so I can do it, I can go from a to o, and then from o to y. So a to o is something that's already given to us, that's minus a, and then oy, as the question suggests, is h times of ox. Now ox is something I believe we've worked out. Yep, we worked it out. It's 1 upon 4a plus 3/4 of b. So I'll just replace it with that. 1 upon 4, yeah. So it's 1 upon 4a plus 3/4 of b. So let me just double check. 1/4 of a, yep, plus 3/4 of b. And there you go. It doesn't say here that you need to give it in its simplest form, does it? Nope, it doesn't. So you can leave it here. Although it's wise to simplify it, but since I don't have a lot of space here, I'm going to leave it here. And then I'll do that in the next part. Now, in the next part, it says, now remember, what we worked out in part C was ay, and what we're working out in part D is also ay. Over here, it says that ay is equals to m times of ac, and ac is something we worked out to be minus a plus 2b. So notice what the question has made us do. It has made us work out the same vector. Let me just write this down first. Minus m times a plus 2mb. Yeah, so it has worked out the same. It has made us work out the same vector, which is ay, but in two different ways. Okay, so ay is also equal to m times of ac. Okay, you can see here that ay is equal to m times of ac, and it has made us work out ay, which is equal to ao plus oy. Okay, so since they're both ay, that means they both must be equal, right? And if they're both equal, that means what I can and what I will do is I will compare their coefficients. Okay, coefficient of a and components, actually not coefficients. I'll compare the components of a. I'll equate the a components and equate the b components and work out the value of h and m, or whatever it is that we have to find. So let me show you what I mean. Now, as far as ay is concerned, there's no need to simplify it further. I can see that the a component is minus m, and I can see that the b component is 2m. But as far as ay from part C is concerned, that requires a bit of fine tuning. So I'm going to write this as 1/4 of h times of a, and you notice how I always write a towards the very end, just makes the whole comparison thing easier, plus 3/4 of h times of b. Now let's write this nicely. So ay is equals to, when I say let's write this nicely, I basically mean that let's write the plus first and then the minus, and then the whole idea of doing this was so that I could take a common. So I'm looking at 1/4 of h minus 1. Now all of this is the a component, plus 3/4 of h times b, and this is the b component. Now this is the part where you compare. Now if you look at the a component from ay from part D, that's equal to minus m, and if you look at the a component of ay from part C, that's equal to 1/4 minus 1. So I'm going to equate the two. I'm going to try and color code this. So I'm looking at minus m is equals to 1/4 of h minus 1. So here's my first equation. Now let's look at the components of b. So the component of b from ay from part D is 2m, and the component of b from ay from part D is equals to 3/4 of h. Now let's switch to green for that. So we have our second equation, which is 2m is equals to 3/4 of h. Now we have two equations, we have two unknowns. We can solve them simultaneously in order to work out the value of m and the value of h. And this is the point where you decide which variable you're going to make subject and where exactly are you going to plug it in. So I'm going to use equation number 2 and make h the subject. So I'm looking at m is equals to 3 upon 8h, and I'm going to plug this in back into equation number 1. So I'm looking at minus 3 upon 8h. The reason why it's minus is because it's minus m is equals to 1/4 of h minus 1. Now be very careful of the signs. In fact, this is the point where I think let's just use a calculator. So we're looking at minus 3 divided by 8. So here's what I'm doing. Minus 3 upon 8h minus 1 upon 4h is equals to minus 1. So from it, let's subtract 1 upon 4. So I'm looking at minus 5 upon 8h, which is equal to minus 1. So the two negatives get cancelled out, and I have the value of h, which is equal to 8 upon 5 by cross multiplying. 5h equals to 8, and you guys are math students, I know you. I'm sure you guys know what I'm doing. And then we work out m. So m is equals to 3 upon 8 times h. So 3 upon 8 times h means 3 upon 8 times 8 upon 5. So the 8 and 8 get cancelled out, and we're looking at 3 upon 5. So we have the value of m, and we have the value of h, and this is exactly how you're supposed to do questions like these. Okay, now we come to another question, and this is question number 9. Follows the same concept more or less, and this, I should mention, is a question from October-November 2020, paper 2, variant 2. Okay, so let's get straight to it. So it says here, find OQ in terms of A and B. So we can do that. That's not going to be a problem, and it's a 1-mark question. So OQ is equal to 2B plus A. I should have read the question first, in fact, so I'm going to do just that. So it says in the diagram, OB is equals to 2P, all right. OS is equals to 3A, okay. SR is equals to P, so SR, okay. So this, by the way, also tells me that OP and SR are parallel because they both are in terms of B, and for the same reason, OS and PQ are also parallel because they both are in terms of A. And then the lines OR and QS intersect at X. Okay, so we go OR and QS intersect at X. We can see that. Okay, now let's do part A, which we've already done. And then let's do part B, which says find QS. So in order to go from Q to S, I have to go from Q to P, and then from P to O, and then from O to S. So I'm looking at minus A minus 2P plus 3A. So when I simplify this, I'm looking at 2A minus 2B. Okay. Yeah, let me double check. Yep, that's correct. Then it says, given that Qx is equals to mu times of Qs, find Ox in terms of A, B, and mu. Okay, so let's do that. Ox. Alright, so if I want to go from O to X, I can go from O to P, and then P to Q, and then Q to X. So I'll have Ox. So let's do just that. So Ox is equals to OP, I'll write it over here, OP plus PQ plus QX. Let me just make sure if that's, yeah. So OP is 2B. So we're looking at 2B plus A plus mu times of QS, and QS is something we already worked out, so we're looking at 2B minus 2A. Now this is not something I'd suggest you simplify, because first of all, we don't have a lot of space, and second of all, we will have to do it later on, and when we have to do it later on, we have plenty of space to do it. Okay, now, and then it says, given that OX is equals to lambda times of OR, find OX in terms of A and B. Okay, so this time I have to find OX, and this time I have to use lambda. Okay, so Ox is equals to lambda times of OR. Okay, so that shouldn't be a problem. Ox is equals to lambda times of OR. So if I can somehow get my hands on OR, all I gotta do is just multiply it by lambda, and we'll have our Ox. Okay, so let's see. OR, is going to be 3A plus B. So OR is 3A plus B, and as the question says that Ox is equals to lambda times of OR, that means Ox is equals to lambda times of 3A plus B. This I would suggest that you write as 3 lambda A plus lambda B, because it's just one extra step that you have to do. Now, very predictable, the question is going to ask us to find the value of lambda and mu, and yep, that's what we have to do now. Notice how, again, the question has made us work out Ox, and both of them, the question made us work out in terms of lambda and also in terms of mu. So I'm going to just copy paste that over here. So here I have Ox from part B, and here I have Ox from part D. So let's put them side by side, and let's see what we have to do. So as far as Ox goes, I'm going to have to simplify it further. So we're looking at 2B plus A plus 2 mu times of A minus 2 mu times of B. So let's get all the A's and B's on one side. So we're looking at 2, in fact, let's write A first. So A plus 2 mu A plus 2B minus 2 mu B. Okay, so let's factor out A from here. So I'll get 1 plus 2 mu A, and then if I factor out B from here, so I'll get 2 minus 2 mu. Remember, to factor out only a and b, you don't, like in over here, you don't necessarily have to factor out 2b, even though you can, because you just want the components of a and b. Now this is the point where we start comparing. So if I look at the component of a from the ox from part b, I suppose, part c, so that's 1 plus 2 mu, and ox from part d is 3 lambda. So I have my first equation, which is 1 plus 2 mu is equals to 3 lambda. So here's my first equation. And then let me color code this. So I'm going to turn this into red. Yeah, there you go. And then let's take green. So here you have 2 minus 2 mu, which is equal to lambda. So that means you're looking at 2 minus 2 mu, which is equal to lambda. And here's your second equation. And thankfully, I can do them with the help of elimination. So I'm just going to add these two equations straight away. So I'm looking at 3 is equals to 4 lambda. That means 4 lambda is equals to 3, which means lambda is equals to 3 upon 4. Okay, once you have the value of lambda, you can use any one of the two equations to work out mu. So I'm going to use the second one. So it says 2 minus 2 mu is equals to lambda. So that means 2 minus 2 mu is equals to 3 upon 4. So we're looking at 2 minus 3 upon 4 is equals to 2 mu. That means 2 minus 3. In fact, let me make a fraction. 2 minus 3 upon 4. So we're looking at 2 mu is equals to 5 upon 4, which means mu is equals to 5 upon 8. And there you go. We have our final answer. Then it says, find the value of qx is to xs. Okay, so let's have a look at qx and let's have a look at xs. In fact, what I'm going to do is, I'm going to take a screenshot of this and put it next to the question. Okay, now here the question wants us to find the value of qx is to xs. So let's have a look at what exactly we want. The question wants us to find qx is to xs. Now if you go back, we already worked out that qx is equals to mu times of qs. Okay, so let me write that down over here because that's what we're going to use. Qx is equals to mu times of qs. Right, let me just double check. Don't want to end up getting the whole thing wrong. Yeah, qx is equals to mu times of qs. Okay, cool. Now we already know what mu is equals to. We know that mu is equals to 5 times 5 upon 8. So if I write this in ratio form, qx upon qs, that means just bringing qs under qx, so I'll have mu upon 1. Now what does this mean? This means if qx is mu, then all of qs is equal to 1. Okay, which further means that xs or xs is going to be 1 minus mu, because so basically instead of values we have this in terms of mu. So I'll explain again. The ratio of qx is to xs is mu is to 1, and qx is mu, and qs, all of it is 1. So if you want just this part, just this part xs, so it's going to be 1 minus mu, and that's what we have. So considering that we already know what mu is equals to, that means we can have the actual value. So we just figured out mu to be equal to 5 upon 8, and if you do 1 minus 5 upon 8, you'll have 3 upon 8. Now notice how they both have upon 8, so that means I can sort of ignore that, and I can say that the ratio of qx is to xs is equals to 5 upon 3. Or if that doesn't sit too well with you, what you can do is you can do 5 upon 8 over 3 upon 8. Ultimately the upon 8 gets cancelled out, and you're looking at 5 upon 3 as your final answer. And just like this part, we're going to do part G also. So let's get straight to it. I'm going to use this picture, so let me just copy paste it over here. Yeah, there you go. Okay, now over here the question wants us to find out the ratio of OR is to OX. So let's go back. The question told us that OX is equals to lambda times of OR. So let's write that down. OX is equals to lambda times of OR. Okay, now we worked out the value of lambda, and that turned out to be 3 upon 4. Now again, I'm going to write OX upon OR, which is equal to lambda upon 1. So that means if OX is lambda, all of OR is 1, which means XR is going to be equal to 1 minus lambda. Now let's see what we can do here. OX, we want the ratio of OR is to OX. So OR is one part, okay? So OR here, so OR upon OX. OR is one part. As far as OX is concerned, OX is equal to lambda, and lambda, as we just found out, was equal to 3 upon 4. So that means all I got to do is replace lambda with 3 upon 4. So 1 upon 3 upon 4 is equals to 4 upon 3. And this right here is your final answer. Now I'm just going to do one more question for you guys, just so that we can sort of just so that you guys understand this concept better. And this time the question that I've chosen is October-November 2018 paper 1 variant 2. Now, because it's sort of a different question and you have some different concepts going on over here. So it says here the vector v has magnitude of 39 units and is in the same direction as minus 12, 5. Write v in the form AB, where A and B are constant. So just to give you guys an idea of what's exactly going on over here, so you have a vector v which has a magnitude of 39 units. So that means this is what you're looking at. This is equal to 39. And it's in the same direction as minus 12 and 5. So that means this is what the direction of the vector is. So minus 12. The reason why it's leftwards is because it's minus 12, and the reason why it's upwards is because it's positive 5. Now, if you recall similar triangles, if I just look at this part of the triangle, so we have one length 5 and the other is 12. So the hypotenuse is going to be 13. So that means just this part of the vector has magnitude 13. Now, if we take the entire vector v into consideration, that has magnitude 39, which means that 39 is 3 times of 13. And that basically tells us that if we were to break down vector v into its components, so we'll have to do minus 12 times 3 and 5 times 3. So that means its horizontal component is going to be, like I said, minus 12 times 3, and its vertical component is going to be 5 times 3. So we're looking at minus 36 and 15. Now, I know you're probably wondering that this is not the way that we were taught. The reason why I did this is just to give you guys an idea of how you work out a vector when you're given its magnitude and the direction. An easier way of doing this would be to take the magnitude, which is 39, and multiply it by the unit vector of the direction vector. So here's what I mean. So that means all you had to do was, if you split this minus 12 and 5 and write it in IJ form, so, or in fact you don't even have to do that. So all you got to do is find out the magnitude of this vector, which we just did. It was equal to 13. So all you got to do is you got to take 13 divided by both the components, minus 12 and 13, and 5 upon 13, and you just need to multiply 39 by both of these values. So 39 multiplied by 12 upon 3 is minus 36, and 39 multiplied by 5 upon 3 is 15, and you get the same answer. So remember, long story short, that if you have a magnitude and the direction vector, you got to take the magnitude multiplied by the unit vector of the direction vector, and that's how you end up with whatever vector it is that you have to find. Anyway, so it says vectors p and q are such that p is equals to r plus s and q is equals to 5r plus r plus s, r plus 6, and q is equals to 5r plus 1 and 2s minus 1, where r and s are constants. Given that 2p plus 3q is equals to 0, 0, find the value of r and the value of s. So this shouldn't be too difficult. 2p means 2 times r plus s, r plus 6, plus 3q means 3 times of 5r plus 1 and 2s minus 1 is equals to 0, 0. Okay, now we're looking at 2r plus 2s and 2r plus 12 plus 15r plus 3 plus 6s minus 3 is equals to 0, 0. So all you got to do is compare. So this is actually a very easy question. Okay, so we're gonna have two equations. One of them will be 2r plus 2s plus 15r plus 3 equals to 0. And then let's simplify this before we move to the next equation. So you have 2r plus 15r, so that's going to be 17r plus 2s, which is equal to minus 3. So here's my first equation. And then let's look at the second equation, which is 2r plus 12 plus 6s minus 3 equals to 0. So we have 2r plus 6s is equals to 3 minus 12 if I take it over to the other side, so that's minus 9. Now here's the second equation. To save some time, I think I'm going to solve this in the calculator. So if I do that, let's see, what do I have? So 17, 2 and minus 3, 2, 6 and minus 9. So I have the value of r as 0 and s is equals to minus 3 upon 2. There you go. This is the final answer and also the correct answer. Anyway, so this brings me to the end of this video. In the next couple of videos, I will try and do a couple of vectors where you have to find constant velocity, and yeah, so I'll see you guys in the next video. Until then, take care. Bye bye.